Wait for the second episode is over. Nobel Prizes 2023.
Professor Claudia Golden from Harvard University won the Nobel Memorial Prize in Economic Science for the year 2023. Her work is cited as the first comprehensive account of women's earning and labor market participation, and rightly so, because she mined data of over 200 years. She is the third woman to win this prize in economics, but the first one to do it solo. Her analysis has demonstrated that women's participation in the labor market did not show an upward trend. Instead, it was a U-shaped curve. Several factors have contributed to this U-shaped curve, which include technological innovation, education, balance between work and family, and laws and regulations. In terms of temporal dimension, there was a larger proportion of women participating in the workforce in the pre-industrialized or the agrarian society. But that reduced in the industrialization era. Why? Because it became difficult to work from home as they couldn't balance the needs of the family. Come the 20th century, and we witnessed a rise in the women workforce. This was mainly because of the growth of the service sector and increasing the level of education among women. But there was a practice of firing and not hiring women once they got married. And the main reason was that of pregnancy. Married women returned to the workforce only when their kids grew up, which is why we don't see a sharp rise in the women participation rates, even though there were more women entering the labor market. Was that all? No. There was another important factor which was determining the women participation in the labor market, and that was the contraceptive pills. This meant that they could plan their career much better. But then we had another problem, which was pay gap. And pay gap between men and women increased significantly with the growth of the service sector. And I recommend you to watch this beautiful documentary on Netflix, which is titled 9 to 5, The Story of a Movement. And that captures this problem of pay gap beautifully, and it's a must watch.
Now let's talk about quantum dots. The Nobel for Chemistry this year was awarded to Managi Bawandi, Louis Bruce, and Alexei Yakimov for discovery of quantum dots. So what are these quantum dots? Quantum dots are basically super small crystals that are only a few nanometers wide. To give you an idea of the scale, if you were to compare the size of a single quantum dot to a football, that's equivalent to comparing the size of that football itself with the rest of our planet Earth. When you synthesize crystals of that size, their optical properties change. And this happens due to the fact that the electrons don't have as much space to move into. And their motion or their activity is dominated by quantum forces. Unlike classical physical forces like gravity, which occurs at our scale. The earliest work in this field was done by Dr. Yakimov in the 80s, who tried to add elements to modify optical properties of glass. He researched glasses tinted with copper chloride because when heated and cooled under different conditions, it led to a glass with varying light absorbing properties. This was because differently sized copper chloride crystals were formed. This gave hope to Dr. Louis Bruce, who in 1983 produced similar crystals in a liquid solution instead of glass. This is particularly important because this allows tuning the parameters more efficiently to study these crystals. 10 years later, Dr. Managi Bawandi, who was once a postdoc with Dr. Louis Bruce, developed quantum dots. These were well-defined, had great optical quality, and a wide range of applications. So they controlled the size of these dots by controlling the temperature at which the substances were injected into the solvent. So where do we see these quantum dots in real life? Very simple. Screens. LEDs behind the screens excite these quantum dots to emit lights of different colors. They also find applications in the biomedical world, in imaging and targeted drug delivery. They can also be used as security markers in currency and as possible counterfeit measure in documents.
Pierre Agostini, Franz Krauss, and Anne Louis won the Nobel Prize in Physics for the year 2023. Their experiments allowed scientists to generate attosecond pulses of light. It might be hard to digest what an attosecond is without context. An attosecond is to a second what a second is to the age of the universe. An attosecond is a billionth of a second. You might be wondering, why is this helpful? With the discovery of attosecond pulses, scientists can now study the dynamics of electrons within matter. Scientists can now understand how electrons can move and transmit energy, which can help in creating efficient gadgets. Another application of this discovery is to study the molecular level changes in blood, which can in turn help scientists study diseases. Until the 1980s, scientists were able to produce femtosecond light pulses, which were millionth of a billionth of a second. And these were believed to be the shortest achievable duration of light pulses. Then in 1987, Louis discovered that when a laser wave is passed through a noble gas, it produces ultraviolet light overtones. In simple terms, pulses of light. And these pulses were found to be useful enough for practical use. Then, a few years later, in 2001, Pierre Agostini successfully produced a series of light pulses where each pulse lasted for just 250 attoseconds. His contemporary, Franz Krauss, developed a technique which enabled separation of individual 650 attosecond pulses from a pulse train. It was these flashes of lights that made it possible to provide images of processes inside the atoms. While this discovery makes it possible for us to understand the mechanisms governed by electrons, we are looking forward to utilizing these mechanisms to ensure a better future for generations to come.
Hey guys! If you liked our content, please don't forget to like, share, and subscribe.
We'll be returning back with more episodes and specials.
Stay tuned, stay curious.